Hello, welcome to Prajim Technologies. I am Venkat. This is part 1 of .NET Basics. In this session, we'll understand how a .NET program executes. And to understand this better, we will compare a pre-.NET program execution with .NET program execution. Now, even before .NET came into existence, we were developing applications using programming languages like VB6, C++, etc. Okay, now when I use VB6 and develop an application, let's say a pre.NET application, and compile that using the language compiler, we know that an assembly gets generated. And by the way, assemblies have an extension of .dll or .exe depending on the type of application that we are creating, which we'll talk about in a bit. Now, so this assembly is a native code or a machine code format. Why in the first place do we need to compile an application? Because the operating system can only understand zeros and ones. They can't understand high-level programming languages like C, C++, C#, etc. They are meant to be used by programmers. So programmers use these high-level languages. They develop the application. But whereas your underlying, your computer systems can only understand zeros and ones. So if your program has to execute on top of that operating system, somebody in between has to convert that high-level programming language into zeros and ones, which is nothing but the machine code which that underlying operating system can understand. And to do that, we take the help of compilers, because it's practically impossible for human beings to code using zeros and ones. That's why we have these high-level programming languages. Okay, so the problem with this style of application execution is that this application now, no, look at this. I have a VB6 application, a program. I compiled that. I have this assembly generated. Basically, we deploy the assembly onto a system to get executed. Okay, so this assembly is a native code, meaning this code, this machine code that is generated, is native to that operating system upon which this application is compiled. If I take this program and try to run it on another operating system, for example, in this example, let's say this is Windows operating system. Now, if I take this assembly, which is compiled on this Windows operating system, and if I try to run it on a Linux or a Unix operating system, it will fail to run. Why? Because this code, this machine level code, is native to that operating system upon which it is compiled. Okay, that's the reason why it's called as native code. And some people also call it as object code. Alright, so that's the problem with pre.NET applications. The applications are not portable. Now let's look at how a .NET application executes. Okay, now with .NET you have the choice to pick your programming language. Okay, .NET supports several programming languages like C#, VB, C++, and J#, out of the box, but there are several other languages as well. Okay, if we have a compiler implemented within .NET, you can use any programming language. That's why I have this others box here. Okay, but these four, C#, VB, C++, and J# are the common .NET languages that are being used today. So when I use any of these programming language and develop a .NET application, and then when I compile a .NET application, okay, we get an assembly here as well. But this assembly does not contain native code. Instead, it contains intermediate language. So, okay, that is the difference between a .NET assembly and a pre.NET assembly. Okay, before .NET, the assemblies are in native code format, but with .NET, the assemblies are in intermediate language format. But keep in mind, the operating systems can, understand only zeros and ones. So if you run this assembly directly on top of the operating system, will the operating system understand that? No, it will not, and it will fail to run. That's why there has to be somebody in between who will convert this intermediate language into native code which this operating system can understand. And who will do that job for us? The runtime environment called CLR. Common Language Runtime Environment. And how did the CLR come on this machine? Now when I install .NET on a computer, there are two important components that gets installed. Okay, one is the .NET Framework class library, and the other one is the CLR, the runtime environment, Common Language Runtime. Okay, so this CLR is the heart of .NET program execution. So when the program tries to run, we know that intermediate language cannot be understood by the operating system. So this assembly actually, it doesn't run directly on top of the operating system. Okay, there is a layer in between called CLR. Okay, within the CLR, this assembly tries to execute, and within that CLR we have another important component called JIT compiler, which takes in intermediate language as the input and emits native code. It generates native code, and this code can be understood by this operating system. Okay, so if you look at this, within .NET program execution we have two steps. One, from source code to intermediate language, done by the respective language compiler. Okay, from source code to intermediate language, done by the respective language compiler. And then step 2, intermediate language is converted into native code by the JIT compiler, and this JIT compiler is residing on CLR. And what is CLR? CLR is the runtime environment for .NET applications. And how did it get in there? When I install .NET on a computer, we have two important components gets automatically installed. One is the framework class library, and the other one is the runtime environment. Okay, now what is the advantage of executing a program like this? The number one advantage is portability. Now let's assume this operating system is Windows. So on top of this Windows operating system I have CLR. So obviously when this program executes, the CLR on top of this Windows operating system will take that intermediate language. Okay, at the time the program is executing, the JIT compiler will convert that intermediate language into native code which this underlying Windows operating system can understand. Okay, and along the same lines, let's say for example I have Unix operating system. If this operating system is Unix, then we have a runtime environment that is installed on that operating system which is suitable for Unix, which will convert the intermediate language into native code which the underlying Unix operating system can understand. So what I mean to say here is, as long as the platform has the CLR implemented, on any of those platforms your .NET program can run. Okay, because the CLR, the JIT compiler within the CLR on top of that platform will take up the responsibility of converting intermediate language into native code which that underlying operating system can understand. So this way .NET applications are portable from one platform to another platform. So this is like this virtual environment which is providing us with that capability. Not only application portability, another very important feature provided by CLR is garbage collection. Now if you are from a VB6 or a C++ background, usually when we are developing applications, let's say for example I have a customer class, I create an instance of that customer class. So what happens? Memory gets allocated to that object. Now after I am done using that object, as a programmer I am responsible for deallocating the memory for that object. Otherwise what happens? Memory overflow exceptions, because you didn't clean the objects tend to remain in memory. At some point the application is going to break. Okay, and often novice developers tend to forget cleaning up memory. Okay, which will present us with hard to detect runtime errors or memory overflow exceptions, etc. Okay, but whereas with .NET you don't have that headache anymore. Okay, you as a programmer create objects, use them, and forget about it. Who is going to clean those objects afterwards? Garbage collection. Okay, your runtime environment has another important component called garbage collector, which will clean the objects that are not in use. We as programmers are not responsible for memory management, but before .NET we were responsible for memory management, and we often used to forget and present us with this memory exceptions. But with .NET we don't have that problem anymore right now. Okay, so if you look at CLR, two very important advantages that we have discussed so far. One is portability, application portability, and the other one is automatic memory management, which is also called as garbage collection. Besides these two, there are several other benefits as well, which we'll be talking about in a later session. So there are a few points that we need to recap. So we know that when we compile a .NET application, intermediate language is generated, and different people call it with different names. Some people call it as MSIL, standing for Microsoft Intermediate Language. Some people call it as CIL, CIL, Common Intermediate Language. Okay, and it is also often referred to as managed code. Why do we call intermediate language as managed code? Look at this here. Who is managing how this program runs? Your CLR. Okay, so this intermediate language, which is the byproduct of compiling a .NET application. So this intermediate language runs inside the CLR, and your CLR manages how this application runs within that virtual environment. Okay, it provides memory management, for example. Okay, that's why your CLR is managing that intermediate language, and hence it's called as managed code. So it's also called as managed code. And on the other hand, here we don't have any kind of environment. Here in a pre.NET application, this code directly runs on top of the operating system. Okay, so there's no one managing those objects there. We as programmers are responsible for that. Okay, so this native code is also called as unmanaged code, whereas intermediate language is called as managed code. Okay, and we have seen assemblies have an extension of .dll or .exe depending on the type of the application. For example, if you look at this very simple solution that I have here, it has got one project called Introduction to C#, and this is a console application. So if I right click that solution and then build solution, and then if I right click on the project and say open folder in Windows Explorer, now when I say build, what happens? The source code in this program gets compiled into an assembly. So when I open this folder by right clicking on that and say open folder in Windows Explorer, and if I get into the bin debug directory, you see there a .exe. This is nothing but the assembly. Okay, so since this is a console application, I get a .exe, but on the other hand, I can also add another new project. And if you look at this, in this console application, we are using C# programming language. Now I can also develop another project in the same solution, and I can choose a programming language of my choice. For example, I want to develop a Visual Basic program. I can do that. Instead of Visual C#, I will choose Visual Basic. And then let's say I'm developing a class library project and click OK. Now you look at this, it's a VB project. So it's possible within .NET you can use different programming languages. And now when I build this solution, and if I right click on this class library project and say open folder in Windows Explorer, and if I get into the bin directory and then debug, look at this, we get a .dll. So basically the point I'm trying to prove here is that depending on the type of the application you're creating, you get a .dll or a .exe. But they are nothing but assemblies, both of them. For example, if I create a Windows application, I get another .exe, but whereas when I create a web application, I get a .dll. Okay, irrespective of whether it is a .dll or a .exe, both of them will be in intermediate language format if it is a .NET application. But whereas pre.NET, a VB6 or a C++ application before .NET, when you compile that, you still used to get an assembly which is nothing but .dll or .exe, but those assemblies are in native code format, whereas .NET assemblies are in intermediate language format. Okay, so .NET assemblies contain IL, whereas pre.NET assemblies contains native code, which is also called as machine code or unmanaged code. And the .NET application execution consists of two steps. Okay, one is the compilation itself, source code to intermediate language, and from intermediate language to native code, platform specific native code. And who does that? JIT compiler. And where is the JIT compiler present? It's present in the CLR. And what is CLR called as? It's the .NET runtime environment. So .NET Runtime Environment provides several benefits. Garbage collection is one of them. Application portability is another advantage. Besides these two, we have several other advantages as well, which we'll be talking about in a later session. And .NET supports different programming languages, which we have seen: C#, VB, J#, and C++. So if you look at .NET, C#, VB, C++, and J#. Now, except C++, J#, VB, and C#, they can only generate managed code. But whereas C++ can generate both managed as well as unmanaged code, meaning native as well as intermediate language. Why have they given this flexibility for C++? Because before .NET there were several applications that were developed in C++ for backward compatibility, from .NET applications to pre-.NET applications. They have provided us with this flexibility. So if there is ever a need for your .NET application to generate native code, then C++ is the programming language that we have to be using. Okay, and another important thing to keep in mind is that when you basically run a .NET application, okay, we know that this intermediate language. Now, if you look at this, the assembly, for example, if you take this project, if I open the folder in Windows Explorer, go into the bin, if you look at this assembly, we know that a .NET assembly contains intermediate language. Okay, so this assembly contains intermediate language. When I run this program, what happens? This intermediate language within this assembly is converted into native code by the CLR. So where is that native code stored? It is stored in memory for the lifetime of the execution of your application. But when you close your program, what happens to this native code? Is it stored anywhere? No, it is just thrown away. Okay, so when I run my program again, what's going to happen? This assembly will be loaded into CLR, and the JIT compiler will convert the intermediate language into the native code, and then the program gets executed. So every time you run a program, it has to convert the intermediate language into native code. So obviously we have seen the advantages of this two-step execution model, or this virtual environment execution model within .NET. But what is the disadvantage? The disadvantage is when you first run a .NET application, because of this extra step, compilation of intermediate language into native code, okay, will take a little time, and that's almost negligible. So when you run a .NET application first time, it might be a little slow, but as you continue to use it, it will be faster. But the first use, it will be a little slow. Why? Because there is that extra step of JIT compilation, just-in-time compilation. Okay, now this kind of a program execution model is actually very much similar to Java. If you are a Java programmer, then you might be, you are already aware for Java, the runtime environment is called as JVM, Java Virtual Machine. Okay, and instead of intermediate language, in Java we have bytecode. So when you compile a Java application, what happens? Bytecodes are generated, and those bytecodes run on top of that JVM, Java Virtual Machine, which will convert the bytecodes into native code which the underlying operating system can understand. So in .NET we are essentially following the same approach, the virtual execution model. Alright. On this slide, you can find resources for ASP.NET and C# interview questions. That's it for today. Thank you for listening. Have a great day.